All right, let's dive into one of the most mind-bending questions in all of cosmology. And I know it sounds like something straight out of science fiction, but this idea is actually rooted in some very real and very, very strange science.
So here it is. Could our entire existence, I mean everything, all the galaxies, stars, you, me, could it all be happening inside the event horizon of a black hole? It is a seriously wild thought, but there are a couple of clues that have made scientists sit up and really consider it.
And our first clue is a big one. It's a cosmic coincidence, a strange and frankly startling parallel in the math that's just, well, it's hard to ignore. So, just to make sure we're all on the same page, let's do a quick refresher. A black hole, right, is a spot in space-time where gravity is so ridiculously strong that everything, all possible paths, just curve back in on themselves. Nothing can get out, not even light. That boundary, that literal point of no return, is called the event horizon. And for what we're talking about today, you can basically think of the event horizon as the size of the black hole. The more stuff you throw in, the more massive it gets, and the bigger that event horizon grows. Now, here's the thing. Our universe has a horizon too, but it's a different kind of beast. It's not a physical wall, it's a boundary in time. It's simply the farthest we can possibly see because the universe just isn't old enough for light from any farther away to have reached us yet. So you've got two different horizons, the black hole's physical edge and the universe's observational limit. And this is where it gets really weird. If you calculate the size of a black hole that has the same mass as our entire observable universe, you get a size that is shockingly, almost perfectly, the same size as our observable universe. The numbers just line up, the density matches. Now, is that just a crazy coincidence? Or is it our first real clue? Okay, that brings us to the second piece of this puzzle. This one's a lot more recent, and it comes from a really strange observation about the way galaxies seem to be spinning out there in the cosmos. So, a recent study looked at a few hundred spiral galaxies. The idea was simple. Check which way they're spinning. You'd totally expect it to be random, right? About half should spin one way, half the other. It should all cancel out. But that is not what they found. Instead of that nice, neat 50-50 split they were expecting, the researchers found that about two-thirds of the galaxies they looked at were spinning in the opposite direction of our own Milky Way. Now, it's not a perfect alignment, but that is a huge deviation from random. It suggests the universe might actually have a net spin, a preferred direction of rotation. And that is a very, very strange thing. So why is a spinning universe so weird? I mean, why is that a big deal? Because according to everything we think we know about how the universe formed, it just shouldn't be happening. Think about an ice skater for a second. You see, pretty much everything that spins in the universe, planets, stars, whole galaxies, they all started as these huge collapsing clouds of gas. And as those clouds fell in on themselves, any tiny random little jitters inside them got amplified. We call this the conservation of angular momentum. It is the exact same reason an ice skater spins way faster when they pull their arms in. So here's the crucial point. Yeah, individual galaxies are supposed to spin, but the little motions that started it all were totally random. There's just no reason to think that the spin of a galaxy over here should have anything to do with a galaxy billions of light years away. The universe as a whole should have zero net spin. And yet, this new evidence hints that it might. And this right here is where our two mysteries, the weird density coincidence and the universe's strange spin, might just click together. One single, kind of beautiful idea could potentially explain both. You see, physics tells us that when matter falls into a black hole, most of the information about it gets wiped out. But the black hole remembers a couple of key things. It remembers its total mass, and it remembers its total angular momentum. Its spin. If you have a bunch of stuff spiraling into it, the black hole itself inherits that spin. Now, this is a major headache for the standard Big Bang theory. We tend to think of the Big Bang as this perfectly even explosion, outwards in all directions. There's no obvious way for that kind of event to give the entire universe a built-in, collective spin right from the get-go.
But what if our universe didn't start with a Big Bang in that traditional sense? What if our universe is what happens inside a black hole? Well, then our universe could have simply inherited its net spin from whatever material fell into its parent black hole. This one idea could solve both problems in one fell swoop.
Okay, so let's take a step back. It's a beautiful, mind-bending theory that seems to tie everything together so neatly. But how does it actually hold up? let's put this idea on trial and look at the evidence. So what's the verdict? Can we say for sure that we're all living inside a black hole? Is the evidence strong enough to go ahead and rewrite all the textbooks? The short answer is no. Not yet. That density match is still officially just an intriguing coincidence. And the evidence for universal spin? It's really preliminary. Right now, this whole idea remains a fascinating but totally unconfirmed hypothesis. And there are some really good reasons to be cautious here. I mean, that galaxy spin study, it was based on just a few hundred galaxies. There are hundreds of billions of galaxies out there. That is a tiny, tiny sample size. The scientific process, as it should, demands that these results get tested and retested and confirmed by totally different teams before we can accept them. It's a super exciting lead, but we need so much more data. So while we definitely don't have a final answer, the possibility, just the sheer possibility, that our universe is nested inside a black hole is still one of the most profound and exciting questions in all of science. It just pushes the absolute boundaries of what we know and reminds us that there is so much mystery out there still waiting to be discovered. Until next time, keep looking up.